So we want to find points x, y at which the curve r equals 2 cosine of theta, theta between -pi/6 and pi/3 has a vertical tangent line and a horizontal tangent line. Two things to pay attention is, number one, the final answer has to be a coordinate, Cartesian coordinate point, because it says find points x, y. So whatever we find, we have to make sure that our final answer is in Cartesian coordinate. The second thing that we have to pay attention is r equals 2 cosine of theta. Now we have a polar form, so we have to convert that to Cartesian, work with it. And the third thing to pay attention to is that theta is between -pi/6 and pi/3. So we have restricted domain. So let's see. Let's start with x equal r cosine of theta. So let me change color. X equal r cosine of theta. So x equal r is given to us as 2 cosine of theta. So 2 cosine of theta for r times another cosine of theta. And so x equals 2 cosine squared of theta. And how about y? Y equals r sine of theta. So y equals r is given to us as 2 cosine of theta times sine of theta, which is 2 sine theta cosine theta. So I can claim that y equals sine of 2 theta. So let's go ahead and go to the next page. Let's start with vertical tangent line for, vertical tangent line. So for vertical tangent line, I'm going to put in parentheses that dx d theta must equal to 0. So there is no change of x in relation with theta. All right. So first of all, what is dx d theta? If x equals 2 cosine squared of theta, remember, you can write this as 2 cosine of theta quantity squared. That makes your life easier. So dx d theta equal 4 times cosine of theta, okay, times, using chain rule, minus sine theta. So dx d theta equals minus 4 sine theta cosine theta. And we want to set this equal 0. Set equal 0. Let me go ahead and go to the next page. So I have -4 sine theta cosine theta equals 0. Okay, I think the easiest for this one is to just go ahead and divide both sides by -4. So I have sine theta cosine theta equals 0. Sine theta, when sine theta equals 0, theta equals 0 or pi. And pi is not in the given domain, because remember the domain was given between -pi/6 and pi/3. So it was given to us as -pi/6 somewhere right here and pi/3. So pi is not in our domain, but 0 is. And when cosine of theta equals 0, theta equals pi/2 or 3 pi/2. Okay, 3 pi/2 is not in the domain and pi/2 is not in the domain. So 0 is actually, for this problem, 0 is the only choice that we have. So theta equals 0 is the only choice. Okay. When theta equals 0, when theta equals 0, we know that x equals 2 cosine squared of theta. Let me go ahead and go to the next page. So x equals 2 times cosine of 0 is 1. So 1 squared, that gives me just the 2. And y is 2 sine of 0 cosine of 0. And that gives me, well, sine of 0 is 0, so it just brings it to 0. So the Cartesian coordinate point that we're looking for is 2, 0. So 2, 0 was, this is for vertical tangent line, vertical tangent line. Let me go ahead and go to the next page and work on horizontal tangent line. Horizontal tangent line. So we want to set dy d theta equals 0. And dy d theta equals 2 cosine of 2 theta. So set equals 0. Then I get cosine of 2 theta equals 0. So 2 theta equals pi over 2 or 3 pi over 2. Okay. Well, 2 theta equals pi over 2 or 3 pi over 2. I'm going to multiply all sides by 1/2. So I get theta equals pi over 4 or theta equals 3 pi over 4. This is not in the domain, not in the given domain. So pi over 4 is the only choice that I have. Go to the next page. At theta equals pi over 4, we said x equals 2 cosine squared of pi over 4. So x equals 2. Let's see, root 2 over 2, and that's going to be squared. That's going to be 2 times 2 over 4, which is 1/2. So that gives me a 1. And y equals 2 sine of pi over 4 times cosine of pi over 4. So y equals 2 root 2 over 2 times root 2 over 2. That gives me 2 times 2 over 4. 1 again. So the coordinate point that I'm looking for is 1, 1. Okay, thanks.